Welcome to our discussion on climate change, where we will explore strategies for both mitigation and adaptation. Our goal is to understand how to build a more sustainable future for everyone on our planet. Today, we will explore two crucial strategies for addressing climate change: mitigation versus adaptation, understanding their distinct approaches. These are indeed two essential climate strategies, each playing a vital role in our global efforts to combat environmental shifts. Let us begin by looking at mitigation, which focuses on preventing the root causes of climate change from worsening. Mitigation primarily involves taking actions to significantly reduce greenhouse gas emissions, thereby slowing down global warming. It aims to address the fundamental root causes of climate change, such as carbon dioxide and methane emissions. Mitigation is considered a long-term solution because reducing emissions and their effects takes decades to materialize. Key examples include shifting to renewable energy sources and undertaking large-scale afforestation projects to absorb carbon. Now, let us turn our attention to adaptation, which deals with adjusting to the unavoidable impacts of climate change. Adaptation means making necessary adjustments to cope with existing and anticipated climate impacts, minimizing harm to communities. Its primary goal is to effectively manage the consequences of climate change, building resilience against environmental shifts. Adaptation requires immediate and ongoing action, as climate change impacts are already being felt across the globe. Examples include constructing seawalls to protect coastal areas and developing drought-resistant crops for food security. Let's now delve into some of the core mitigation strategies that are vital for combating climate change effectively. Shifting to renewable energy sources like solar and wind power significantly reduces our reliance on fossil fuels. Improving energy efficiency in buildings and transportation helps lower overall energy consumption and emissions. Carbon capture and storage technologies aim to trap CO2 emissions before they enter the atmosphere. Reforestation and afforestation are crucial for absorbing CO2 from the air by planting more trees. Promoting sustainable transportation options, such as electric vehicles and public transit, lowers carbon footprints. Reducing industrial emissions from factories and power plants is another key step toward a cleaner environment. Now, let's explore the key adaptation strategies designed to help us build resilience against climate impacts. These actions are vital for protecting communities and ecosystems from the effects of a changing climate. First, let's consider resilient infrastructure, which is built to withstand extreme weather events. This includes constructing robust flood defenses and seawalls to protect coastal areas from rising sea levels. We also need to build climate-proof buildings that can endure stronger storms, heat waves, and other climate stressors. Next, effective water management is crucial for adapting to altered rainfall patterns and water scarcity. This involves developing crops that are specifically resistant to drought conditions, ensuring food security. Implementing rainwater harvesting systems helps collect and store water for various uses during dry periods. Finally, disaster preparedness is essential for minimizing harm from extreme weather events. Establishing early warning systems for hurricanes, floods, and heat waves can save many lives. We must also plan thoroughly for extreme weather events, ensuring communities are ready to respond effectively. Let us explore the diverse range of renewable energy sources that are powering our sustainable future. These clean energy options are crucial for reducing greenhouse gas emissions and combating climate change. First, we have solar energy, which harnesses the sun's power. Solar energy works by converting sunlight directly into either electricity or usable heat. Next, wind energy utilizes the natural movement of air. Wind energy uses large turbines to efficiently generate electricity from the kinetic energy of wind. Then there is hydropower, which relies on water flow. Hydropower systems generate electricity by harnessing the power of flowing or falling water. Finally, bioenergy is derived from organic matter. Bioenergy is produced from various organic materials and can be used for electricity, heat, or transport fuels. Let's now examine the pros and cons of different renewable energy sources to better understand each option. Understanding these aspects helps us make informed decisions about sustainable energy implementation. Starting with solar energy, which is widely available. It is abundant and emission-free, but its effectiveness is dependent on weather conditions. Next, we look at wind energy, a growing power source. Wind energy is low cost and scalable, yet its supply can be intermittent due to varying wind speeds. Then we consider hydropower, a well-established renewable. Hydropower offers a reliable and large-scale energy supply, but it can disrupt river ecosystems. Finally, bioenergy, which uses organic resources. Bioenergy effectively uses organic waste, but large-scale production risks causing deforestation. Today, we will discuss how to harness nature to reduce carbon and store atmospheric CO2. These natural processes are vital for capturing and storing atmospheric carbon dioxide or CO2. Let's start by defining carbon sequestration, a key process. Carbon sequestration is the process of capturing and storing atmospheric CO2, reducing greenhouse gases. This vital process works to lower the overall levels of greenhouse gases in our atmosphere. It can occur naturally through forests and oceans or artificially using carbon capture and storage technologies. Next, we consider afforestation, which involves creating new forests. Afforestation is the specific practice of planting trees in areas that were not previously forested. This process significantly increases carbon storage, helping to restore and enhance vital ecosystems. Furthermore, it prevents desertification and creates essential habitats for diverse wildlife. Finally, let's look at reforestation, which is about restoring existing forests. Reforestation involves replanting trees in areas that have been cleared or damaged by deforestation. This effort helps restore natural ecosystems and rebuild crucial carbon sinks that absorb CO2. Let us now explore the disaster risk reduction cycle, a framework for managing climate-related hazards. First, we focus on hazard prevention, which involves proactive measures to avoid potential dangers. Next, reducing exposure aims to minimize the impact of hazards on vulnerable communities and assets. Strengthening infrastructure ensures that buildings and systems can withstand extreme weather events. Finally, community awareness and education empower people to prepare for and respond to disasters effectively. We will now discuss building climate-resilient infrastructure, which is crucial for a sustainable future. Flood protection systems, like seawalls and green infrastructure, such as mangroves, guard against rising waters. Earthquake-resistant buildings feature shock-absorbing foundations and reinforced materials for structural integrity. Drought-resistant water systems, including rainwater harvesting and desalination, ensure reliable water access. Energy and transportation resilience involves microgrids and elevated roads and bridges for continuity of services. Let's now focus on achieving food security and water resilience in the face of climate change. These strategies involve adapting agriculture and managing our water resources sustainably for the future. First, we have climate-smart agriculture, an innovative approach. This method increases agricultural productivity and resilience while reducing greenhouse gas emissions. It actively works to reduce greenhouse gas or GHG emissions from various farming practices. Key components include using drought-resistant crops and implementing precision agriculture techniques. Next, sustainable water management is crucial for our planet. This ensures the efficient use, conservation, and protection of our vital freshwater resources. It is critically important for agriculture, providing drinking water and maintaining healthy ecosystems. Strategies include rainwater harvesting, efficient drip irrigation, and advanced desalination processes. To summarize our discussion, let's review the key takeaways we have covered. These are the most important points to remember about climate change mitigation and adaptation. Mitigation aims to reduce emissions, while adaptation focuses on managing the unavoidable impacts of climate change. Transitioning to renewable energy sources is absolutely vital for the decarbonization of our global economy. Carbon sequestration and reforestation are crucial strategies for actively removing CO2 from the atmosphere. Disaster risk reduction, or DRR, and resilient infrastructure are essential for protecting communities from climate hazards. Implementing climate-smart agriculture practices is key to ensuring global food security for everyone. Finally, sustainable water management is fundamental to guaranteeing reliable access to water for all.